All right, so example 2, we're going to graph a rational function. This is a little bit different now because what you see here is we have a squared on top and a squared on the bottom. So the process doesn't change. The process is the same as it was before. The first thing we want to do is we want to look for x-intercepts. The difference here is this is going to require you to remember how to factor. Factoring is going to be important. You're going to want to be able to do this. You need to be able to do this and not, you don't need a graphing calculator to do this, to factor. We've just got to be able to factor. So the idea is because we're setting the top equal to 0 to figure this out, that is the same as factoring. So x squared minus 9, if you recall, factors into two easy things, x plus 3 and x minus 3. Okay? The reason why we know it's plus 3 and minus 3 is because the middle term is absent. Okay? So now that we have our factors, we can say the zeros of the numerator, x squared minus 9, are negative 3. It's going to be plus or minus 3. So 3 and negative 3 are the x-intercepts. Okay, so now we look at the bottom. The bottom factors to x plus 2, x minus 2. Again, why do I know that it's 2 and 2? Well, 2 and 2 is 4, and plus and minus cancels out our middle term. That's why it's just x squared minus 4, and there's no x term in the middle. So therefore, we have plus or minus 2 as our result here. So therefore, x equals 2 and x equals negative 2 will be our vertical asymptotes. So we actually have two vertical asymptotes here. So that's going to make these problems a little bit different. Okay, so the numerator and denominator have the same degree. So this is where we go back to what we did in section 8.2, where we take, this is a 1 and this is a 1. So therefore, because they're the same degree, we will take the ratio of this, of the leading coefficient, and that's what the second rule shows us. Okay, so that means that we have 1 over 1, or just 1. So y equals 1 is our horizontal asymptote. Now, before we do anything else, here's where I want you guys to plot your x-intercepts, plot your vertical asymptotes, and plot your horizontal asymptotes. So I'm going to go to negative 3, 1, 2, 3. I know that we have a point right there. I go 1, 2, 3. I know we have a point right there. Those are my x-intercepts. Now what I'm going to do is I'm going to plot my asymptotes. So we have an asymptote at positive 2 and negative 2. Okay, so it's pretty close. Doesn't have to be exact, obviously, but we're doing the best that we can. Okay, and I'm going to move this real quick so it will be in the right spot. Okay, that's close enough. Okay, and then we have a horizontal asymptote at y equals 1. Excuse the bell, sorry if that was too loud. Okay, so that's basically the very first part of our graph. So now what you see, what we're doing from there is, again, this table, these numbers are just, it tells you exactly. I picked two values to the left of x is negative 2. So here's x is negative 2. There's two values to the left, negative 5 and negative 3. Negative 3 we already know, so we already know that that value is 0, so we don't really need to do more there. But what we will do is we will plug negative 5 into this equation up here to get a value. And we get 16 over 21. And I don't mind if you guys just write a decimal. That's fine. 16 divided by 21, write it as a decimal if that makes it easier. Then we're going to pick, then I did three values between the two asymptotes. So negative 1, 0, and 1. And our values are 8/3, 9/4, and then 8/3 again. And then I picked two values to the right of this asymptote, 3 and 5. We already know that 3 is 0 because it's an intercept. And then for 5, we get 16 over 21 again. So it's the same as what it was way above with negative 5. Okay, and then again, all we're doing is plotting these points. So I go through and plot these points. We're going to do the best that we can. They don't have to be exact, but the idea is once you get approximately what they are, you can start to see what the graph is going to look like. So we have a graph that looks like this. Over here, we have a graph that looks like this. And then in between, make sure you plot those points. That's going to be important where you plot those points. So here we have, I believe it's right above the 2, so like a point right here, and then we have like a point up here, and a point right here. So on a graph like this, you're actually going to have a parabola in the middle. And notice it approaches your asymptotes on both sides. Okay? It goes down and then comes back up. So the horizontal asymptote deals with this graph right here, and then the vertical asymptotes deal with all 3 of them. Okay? Now, the last part about this is domain and range. So this is a little bit tricky. Domain, that shouldn't be as hard. So domain here is just simply all real numbers. See, we're going all the way to the left, all the way to the right, and everything in between. We're doing all real numbers, but because of our asymptotes, we do have restrictions. So we have all real numbers, but we have 2 vertical asymptotes. So therefore, x cannot equal negative 3, and x cannot equal positive 3. So it's all real numbers where x is not equal to negative 3 and x is not equal to positive 3. Okay, so that's your domain. Our range is a little bit trickier as well. Now, we go all the way down. You see these arrows pointing down. That means we're going all the way to negative infinity. So we're going to start with our y is less than. We're going to need 2 separate ones here. Y is less than, and then it's just going to be what our asymptote is, which is 1. So all values where y is less than 1, that's part of it. Also, we have to go up here. We look at our lowest point, and our lowest point here was 9 over 4. So therefore, y can be greater than 9 over 4. So notice, lowest point here is 9 over 4, and then everything above it. So y is greater than 9 over 4. Down here, we have y is less than 1. So in a sense, it's going to be all real numbers except for the numbers that are in between 1 and 9 over 4. Okay, which isn't a big amount of numbers, but we have to make sure that we represent only the values that are going to be represented by y. And nothing between 9 over 4 and 1 is going to be a value, so we can't include that in our range. So you really are going to rely on your graph and the numbers that you get in your table to determine what your values are. So y is less than 1 because we start at 1, go all the way down, and it's not included. Over here, it's y is anything above 9 over 4, and actually, don't forget that it can be equal to as well because it goes right through 9 over 4. Okay, so you have one on the right there to do. When you're ready, hit play, and then the solution will pop up for you. Okay, so if you look at the solution here, these are pretty, these take a little bit of time. And when we get to class, what I'm going to do is I will show you how you can at least get these values right here a little bit quicker using the graphing calculator. I think you guys can figure it out using the tables in the graphing calculator or using the trace function. So that way you don't have to plug everything in individually. But obviously at home it's a little bit more difficult to do that. So here, your x-intercept is 0. So we have x equals 0. The reason is because it's just an x on top. If you plug 0 in, you're going to get 0. So that's why our x-intercept is 0. For the bottom one, we had to factor. We got x plus 4, x minus 4. So therefore our vertical asymptotes were x equals negative 4 and x equals positive 4. And because the degrees were the same, we had to set up the ratio of the leading coefficient, 3 over 1, and that was equal to 3. So we have y equals 3 is our horizontal asymptote, and you see that I've labeled all those as red dotted lines. And then what we have is we have our table here of all of our values. I picked values to the left, negative 5 and negative 6. I picked 3 values in the middle, negative 2, 0, and 2. And then I've picked values to the right, 5 and 6, and then I've plotted them. Again, I plot my x-intercept on the graph. I also plot all my asymptotes, and then I do my table. And then the very last thing here is our domain and range. And for this, our domain is the same thing as what we did before. It's all real numbers, but we still have to take into account our asymptotes. So our asymptotes are positive and negative 4. So you'd say x is not equal to negative 4, x is not equal to positive 4. So it's all real numbers where these two are not equal to negative 4 or 4. And then our range, we have to, again, pay attention to our graph. So you see that it can be y is greater than 3. Okay, it never touches 3, but it goes up from there. So it's anything from 3 up, but it's also anything from 0 down. So y is less than or equal to 0, and nothing in between. So anything between 0 and 3 doesn't really, that's not part of the graph, so that can't be part of our range. Okay, so here's what we're going to do again. And I know this is long, I really apologize, but once we get through it, we are going to spend a little bit of time doing it. We'll have some review next week. We have the lab that we can do some extra work in. So part 3 will be the back side of this paper. So go ahead and just go to part 3 and do that. All right.